this is a very simple question. The function g of x is given as an integral, right? So it is given that, so g of x, the function g of x equals integral x to pi by 2, okay, f dash of t cosecant t minus cot t cosecant t multiplied by f of t dt. Okay, so if you observe, so this is directly the derivative of some function, right? This is the product rule. So cosec t multiplied by the derivative of f of t, and this is f of t multiplied by the derivative of cosec t, which is cot t multiplied by cosecant t, right? So that means the whole expression inside the integral, so that is the derivative. So d by dt of f of t multiplied by cosecant t. So derivative of integral, so directly we can write it, so this is f of t cosec t, so that's all. So that is the integral f of t cosecant t. So now the limit is from x to pi by 2. So let us substitute here. So if you substitute the upper limit here, f of pi by 2, so that value is given to be 3 here. So f of pi by 2 is 3. So minus cosec pi by 2, that is 1. Now x if you substitute, so f of x multiplied by cosecant x. So that is same as 3 minus f of x divided by sin x. This is the function g of x. So we've got the function g of x. Now we have to find the limit. So limit x tends to 0 g of x. So that equals limit x tends to 0, so 3 minus f of x divided by sin x. If you directly substitute the value, right, so f of 0, so that is 0, so 0 divided by 0, 0 by 0 form. So let us use L'Hopital rule. So this is a constant, we can take it out. So 3 minus, so limit x tends to 0, so this is derivative. Let's find the derivative. So that is f dash of 0 divided by sin x, derivative is cos x. So that's all. Simply we can substitute. F dash of 0 is known, right, from the question, right? So this is not 0, it is x. So now we have to substitute 0. So f dash of 0, so that is given to be 1. So that means 3 minus 1. So the answer is simply 2. So that's all, right? Very simple question, because so we don't need to do the integration because it is already the derivative of some function. Integral is very simple. So that will give you the function f of g of x. So g of x is 1. We have to just find the limit. That's it, right? So the answer here is 2. Here some functions are given in the options. We have to see which of these functions can become 0 at some point in the interval 0, 1. Alright, so let us take the functions one by one. Okay, so the first function. So now let us take the first function to be some g of x. Okay, so g of x equals, so that function, so e to the power x minus integral f of t sin t dt. Okay, so this is the given function. Now can this become 0 at some point? Let us see. So first of all, let's find the derivative. So what is the derivative? E to the power x minus, so derivative of this integral, we can use Leibniz rule or we can directly substitute. So f of x sin x. So this is the derivative. So what can you say about this derivative? See, in the interval 0 to 1, this value is always greater than 1. Okay, because e to the power 0, that is 1, so this value is greater than 1 in the interval 0 to 1, but this value is always less than 1 because sin x is less than equal to 1, and also f of x is less than 1 because it is given that in the question. So this is the codomain of the function is 0, 1. That means this value will always lie between 0 and 1. So this is less than 1, this is less than equal to 1. So the whole value is less than 1. But this value is greater than 1. So that means this is bigger than this. So this is always positive. So g dash of x is always positive. So that means it is an increasing function. You understand? So increasing function. So increasing function. For an increasing function, so can it have roots between 0 and 1? Or possible, maximum 1 root is possible. So let us just draw to get an idea. See, this is the function. At 0, what is the value of this g of x? At 0, e to the power 0, 1, and that becomes 0. So at 0 it is 1. And also it is an increasing function. For an increasing function, the graph will be something like this maybe. It is an increasing function. So this will never become 0 in the interval 0 comma 1. Okay, in the interval 0 comma 1, so this value will never become 0 because at 0 it is 1 and it is an increasing function. So this function can never become 0 in the interval 0 comma 1, right? So that is about the first option. Okay, now let us take the next one. So the second one, so that is f of x plus integral 0 to pi by 2 f of t sin t dt. Okay, so now see f of x, which is a positive number. Do you understand? So because f of x has codomain 0 comma 1, so f of x is always a positive number. What about this? So this is f of t sin t, that is positive again because it is 0 to 1. This also lies between 0 and 1 in the interval. So that means this is also a positive number. So both these expressions are positive number. Will you add these two? Will you ever get 0? Okay, this is a positive number. This is a positive number again. So if you add these two values, will it ever become 0? So that means, so this function can never become 0. Alright, so this second option is also not correct. Do you understand? So let us take the third one. Again, let us take g of x to be that function, right? So that is x minus integral 0 to pi by 2 minus x f of t cos t dt. Okay, yes. Now what do we do? Okay, so let us find, let's check whether this function can become 0 at some point in the interval 0 comma 1. So what is the value of g of 0? What is the value of g of 0? So that is 0 minus, so 0 minus integral 0 to pi by 2 f of t cos t dt. Okay, so that is the value of g of 0. So this value is negative. Okay, so g of 0 is negative. Okay, yes. Now what we do? So we'll find g dash of x. G dash of x. Just like the first question. So g dash of x. What is that? 1 minus this derivative. Let us substitute here f of pi by 2 minus x. Cos of pi by 2 minus x. That is sin x multiplied by minus 1. Right? Leibniz rule we have to use. The derivative of this is minus 1. That means this will become plus. So this is again positive because this is a positive number. Sin x is positive, right, in that interval. So that means this whole value is positive. That means it is an increasing function again. Increasing function. So this time also g of x is an increasing function. But g of 0 is a negative value. Okay, g of 0 is a negative value. So the graph may be something like this. At 0 it is a negative value. Okay, and at 0 it is a negative value. And it is an increasing function. At 1 what is the value? At 1 what is the value? So g of 1. So what is g of 1? So 1 minus this value. Okay, what is it? Is it negative or positive? Okay, at 1 this value is positive because this is less than 1, because 1 minus this value is less than 1, right? So pi by 2 minus 1. So f of t, both the values are less than 1. So this whole expression is less than 1, but this is 1. 1 minus a number less than 1. That means it is always a positive value. So at 1 it is a positive value. But at 0 it is a negative value. So that means the graph will definitely intersect at some point between 0 and 1. So that means, so that is the conclusion. G of x can be equal to 0 for some x. Do you understand? So this function can be 0 at some value of x in the interval 0 to 1. You understand? So that is the third option. Okay, so the next one, x to the power 9 minus f of x, right? So can that value be equal to 0 at some point? So let us take that one. So let us take again g of x equal to x to the power 9 minus f of x. So this is g of x. Okay, so can this be 0 at some point? So let us find. Okay, now what is the value at 0? Okay, g of 0. So this 0 minus f of 0. Whatever is f of 0, but this value is always positive, minus of that is negative. So g of 0 is always negative. Okay, yes. Now next one, g of 1. So what is g of 1 here? So 1 minus f of 1. Again, f of 1 is less than 1. Okay, f of 1 is less than 1 because it lies between 0 and 1. So less than 1 minus a number less than 1. So that means it is positive number. So same idea we are using for all the questions here. G of 0 is negative. At 0 it is negative. At 1 it is a positive number. At 1 it is some value positive, which means the graph will definitely intersect at some point, which means this time also g of x equal to 0 for some x. in that interval. Okay, so that means, so this value, this function, right, x to the power 9 minus f of x can be 0 at some point in the interval 0 comma 1, and similarly this function also, x minus. So these are the two functions which can be 0. The first two can never be 0 in the interval 0 comma 1. Okay. Here this I is given as the summation of an integral. We don't need to find the exact value of I, we have to find the upper and lower limit, right? Some inequality we have to find. So let us find it. See, it is given that the function, see, the integral limit is from k to k plus 1. That means x value is greater than k and less than k plus 1. So x is greater than k. So x is greater than k. That means x plus 1 is greater than k plus 1. Now the reciprocal, so 1 by x plus 1. So that is less than 1 by k plus 1. So what we are going to do is, so this k plus 1 divided by x multiplied by x plus 1. We are multiplying both the sides by k plus 1 divided by x. So that is less than k plus 1 by x multiplied by k plus 1. So this k plus 1 gets cancelled. So we will get k plus 1 divided by x multiplied by x plus 1. So that is less than k plus 1 cancels, so 1 divided by x. So this is the integrand given. So k plus 1 divided by x, x plus 1, that is less than 1 by x. So that means the given integral I is actually less than the summation. Okay, so k is from 1 to 98 integral k to k plus 1, and that integral value is less than 1 by x. So this whole value is less than 1 by x. Okay, so that's all. So this integral we can easily find. 1 by x integral is log x, that's all. So this is summation. So k is from 1 to 98. So this is log x, right? Log base e of x, where it is from k to k plus 1. So that will give you summation k from 1 to 98. So this is log of k plus 1 minus log of k. This looks like the telescopic series, right? So you just substitute the values of k, 1, 2, 3 up to 98. So many terms will get cancelled. Only first term and the last term will be left. So if you substitute the value of k, 1, 2, 3, etc. So we'll get log 2 minus log 1. That is the first term, log 2 minus log 1. Similarly, the next term, so that is log 3 minus log 2, etc. So many terms you will get. The last term is log 99 minus log 98. Okay, now if you observe, so many terms get cancelled, right? Log 2 and here log minus log 2, log 3 will get cancelled, so log 98 also. So this is the term left, log 99, and log 1 is 0, so log 99. So the whole I is less than log of 99 to the base e. So that's all. So that is the conclusion. I is less than log 99 base e, right? So that is one inequality. Now similarly we have to find the other inequality. Okay, for that we'll use a different expression here. Here x is less than x plus 1, right? So x is less than x plus 1. Now that means 1 by x, the reciprocal. So 1 by x or k plus 1 divided by x. So that is greater than k plus 1 divided by x plus 1. Alright, so we just take reciprocal. So inequality reverses, k plus 1 is multiplied. But we want x multiplied by x plus 1. So multiply both the sides by x plus 1. So it will become square. Okay, now this is the given expression, right? Now do the integration and find the summation. So let us do the integration, summation. So k is from 1 to 98 integral k to k plus 1. So k plus 1 divided by x, x plus 1 dx. So that is greater than, so this value again. So summation k is from 1 to 98 and k to k plus 1, k plus 1 divided by x plus 1 square dx. Okay, yes. Now let us do that integral. That is easy to do because k plus 1 is constant. 1 divided by x plus 1 square. So that has integral minus 1 divided by x plus 1. So that is actually summation k from 1 to 98. So this is k plus 1 multiplied by minus 1 divided by x plus 1. The limit is from k to k plus 1. So that is, now you substitute the limits. Okay, if you substitute lower limit, so you get 1 divided by k plus 1. So that k plus 1 gets cancelled, right? So 1, simply will get summation 1 minus, now upper limit is k plus 1 divided by k plus 2. So that is, so k is from 1 to 98. So this will become simply k plus 2 minus of k plus 1, that is just 1 divided by summation 1 divided by k plus 2, where k is from 1 to 98. So that value is, so just substitute, right? So k is 1 first, so 1 by 3. Next 1 by 4 plus 1 by 5, etc. up to last term is 1 by 100. So this value is greater than this. Okay, now to get the answer, we have to do some adjustment here. 1 by 3 is greater than 1 by 100. So 1 by 3 is greater than 1 by 100. So greater than only, not equal to. We are not writing the value is exactly equal to 1 by 3. We can write anything which is greater than 1 by 3. So 1 by 3 is greater than 1 by 100. 1 by 100 is smaller, right? 1 by 3 is greater than 1 by 100. 1 by 4 is also greater than 1 by 100, etc. up to, so 1 by 100 as it is. So each value is greater than 1 by 100. So how many times? From 3 to 100, so we have 98 terms. So 98 times we have 1 by 100. So which means the whole value is greater than 98 divided by 100. Okay, so 98 by 100, so that is 49 divided by 50. You understand? So this whole value is greater than 49 divided by 50. That's all, right? So we have to do some adjustments here, because we don't write exact value here to get the answer, right? So we have to write this expression which is greater than that. Okay, so this value 1 by 3 is greater than 1 by 100. Each value is greater than 1 by 100. If you add only, then we get the value 49 by 50. So the given integral, right, I is greater than 49 by 50, and also this I is less than log of 99 base e, right? So that's all. So this is the answer. Here the function g of x is given as an integral with variable limits. So we have to find the derivative using Leibniz rule. Yes, let us find the derivative. So g of x is given to be integral sine x to sine 2x sine inverse of t dt. Okay, yes. Now let us find the derivative of this using Leibniz rule. So let us find g dash of x. So g dash of x equals, so first let's substitute the upper limit. So sine inverse of sine 2x. Sine inverse of sine 2x minus, okay, multiply by the derivative of sine 2x. So that is 2 cos 2x. So that also is to be multiplied 2 cos 2x minus, now substitute the lower limit. So sine inverse of sine x. Sine inverse of sine x multiplied by derivative of sine x, that is cos x. So this is Leibniz rule, right? Upper limit and its derivative minus similarly the lower limit. Okay, so done. Now this is g dash of x. Now we have to find g dash at a point, say pi by 2 and minus pi by 2. Let us substitute one by one. So we can't write sine inverse sine 2x as 2x, right? We don't know whether this 2x is within the range or not. So let us find it one by one. So first let us find g dash of pi by 2. So g dash of pi by 2, so that means we get sine inverse of sine 2 pi by 2. So that is pi multiplied by 2. So this is cos pi, okay, 2x. So that is pi. So cos pi minus sine inverse of sine x. So sine inverse of sine pi by 2 and cos pi by 2. Okay, what is sine inverse of sine pi? That is not pi, because sine pi is 0. So sine inverse of 0, so that is 0. So the whole value is 0. So 0 is the value of this. Now sine inverse of sine pi by 2, whatever it is, cos pi by 2 is 0. So that means the whole value is 0. Okay, so 0 is the value of g dash of pi by 2. Okay, done. Now similarly, we will find g dash of minus pi by 2. So what is g dash of minus pi by 2? So let us write the same thing again. So we did not write all that directly, we can write it. But still, minus pi and 2 cos, so that will be same, cos even function. So minus sine inverse of sine minus pi by 2 and cos of pi by 2 only. So again the same value, right? So sine minus pi is also 0. So sine inverse of 0, 0. So the whole value becomes 0. Cos pi by 2 again is 0. So that means, so g dash of minus pi by 2 is also 0. Okay, so that means, so these options do not match. So that's why we have 5 options, right? Actually in the question we had only 4 options, but none of the options match. here. So that means that's why I created one extra option, right? So g dash of pi by 2 is 0 or g dash of minus pi by 2. So that is also 0, right? So that is the answer. This is a very usual question. We have to use the properties of definite integral. That's it, right? So the given integral is taken as, say, I. Okay, let's call the given integral to be I. So minus pi by 2 to pi by 2 x square cos x divided by 1 plus e to the power x dx. So we are just going to use the property, right? F of a plus b minus x, right? So in place of x we can write a plus b minus x. The value of integral will remain the same. So what you do? You replace x by a plus b. But what is a plus b? Minus pi by 2 plus pi by 2, that is 0. So 0 minus x. So when you replace x by minus x, f of minus x, so we'll get the same value. So that means the same I equals, so minus pi by 2 to pi by 2. So x is replaced by minus x. So this remains same, x square, and cos x is even function again. So divided by, so this is 1 plus e to the power minus x. Okay, so that's all. So we've used the property that f of x is same as f of a plus b minus x, the integral of that, right? So when the limit is from a to b. Okay, yes, done. Now, so let me write it here. So we've just used the property a to b f of x dx. So this integral is same as integral a to b f of a plus b minus x dx. So this is the property of the definite integral, so that we've used here. Okay, now let us simplify this further. So this becomes, so this e to the power minus x can be written as 1 divided by e to the power x. So this is minus pi by 2 to pi by 2 x square cos x divided by, so this is e to the power x plus 1 multiplied by e to the power x dx. Okay, yes. Now the given integral, that is, say, equation number 1. So this is equation number 2. So we can simply add these two, right? So add these two equations. Okay. So if you add these two, we'll get I plus I. So that is 2i. 2i equal to integral minus pi by 2 to pi by 2. So these values are common, right? X square cos x divided by 1 plus e to the power x. X square cos x by 1 plus e to the power x. So x square cos x divided by e to the power x plus 1 multiplied by, here it is 1 plus e to the power x. So 1 plus e to the power x dx. So this gets cancelled. So simply our function is x square cos x. We have to integrate x square cos x from minus pi by 2 to pi by 2. And it is an even function now. X square is an even function and so is cos x. So that means this can also be written as 2 times integral 0 to pi by 2 x square cos x. Okay, so that is 2 times our required answer I, right? So 2i equal to 2 times this value. Now we have to find I, or we can write I equal to, so integral 0 to pi by 2 x square cos x dx. So let us do the integration of this now. So x square cos x. How will you do the integration? We have to use integration by parts, right? So take this as u and this as v, right? So ub, right? So we have to use integration of uv. So let us take this x square as u and cos x can be taken as v. So let us do the integration. What is the formula of integration? We have to do integration by part 2 times, right? But instead of that, so we can also use this formula. So I is equal to, so u multiplied by integration of cos x. So that is sin x, which means x square sin x minus, so we can use this formula, right? The continuous integration, right? X square integration of this, and the next term is this x square derivative. What is the derivative of x square? So that is 2x multiplied by integration of sin x, right? Derivative of this integration of sin x, which is minus cos x, and the next term plus, and 2x derivative. What is the derivative of 2x? 2, and integration of minus cos x, so that is minus sin x. Next time again we have to do the integration of 2, so that is 0, right? So after this all the terms are 0. So we've got, so this is the first term u, then u dash, u double dash, right? Derivative. But here we have to do the integration. Sin x integration is minus cos x integration is minus sin x. You keep integrating the second function, and the first function is differentiated, okay, until we get 0. Okay, the next derivative is 0. So that's all. So this is our required function. Now we have to substitute the limits. Okay, it is from 0 to pi by 2. So let us substitute this limit. So if you substitute pi by 2, this is pi square by 2 pi square by 4, and then minus 2x. Here if you substitute pi by 2, that will become 0, and here it is pi by 2, so minus 2. Okay, and then substitute 0. So if you substitute 0, this will become 0, 0, and sin 0, 0. So that's all. So this is the required answer. So I equal to, so pi square by 4 minus 2. So that is the required answer. This is a very standard question. We simply use the this idea, right? In most of the definite integral question, we use this idea only. Integral a to b f of x dx. This is the most important property of all. So it is a to b f of a plus b minus x. Simply use that method, and then you just add these two, then these terms get cancelled, we get a simple integral x square cos x, and then we have to do the integration by parts. Okay, so that is the required answer, pi square by 4 minus 2. Here an equation is given with some integral. We have to find the number of solutions of this equation in the interval 0 to 1, right? So this is the equation given. So that is integral 0 to x t square divided by 1 plus t to the power 4 dt. So that equals 2x minus 1. So this is the equation given. So what we are going to do is, let's consider this left hand side to be one function and right hand side to be another function. Let us draw the graph of this and that and see how many intersections are there. Number of intersections is same as the number of solutions. Alright, so let us find this. Let us take this left hand side, so that I am taking as f of x. So that is integral 0 to x t square divided by 1 plus t to the power 4. Okay, so let's find the derivative. Obviously we have to differentiate this because this is integral with variable limit, so we have to differentiate. So that is direct Leibniz rule. Okay, directly substitute x square divided by 1 plus x to the power 4. So this is the derivative of the function. Now what can you say about the derivative? This is always positive, right? X square 1 plus x square. Not only that, so if you divide the numerator and denominator by x square, we get 1 divided by 1 by x square plus x square. So as we know, it's a positive number plus its reciprocal is always greater than equal to 2. A number plus reciprocal, that is always greater than equal to 2, and reciprocal of that, so this value is always less than equal to 1 by 2. Okay, this value is greater than equal to 2, reciprocal that less than equal to 1 by 2. So that is some understanding from this function, right? Derivative, but we don't want the derivative, we have to draw the given curve, right? This equation, right? This function. So let us draw this. So what is the value of f of 0? F of 0 is 0. So f of 0 value is 0, 0 to 0, so that is 0. But what is the value of f of 1? So let us find f of 1. For that, let us use Lagrange's mean value theorem. Okay, what is Lagrange's mean value theorem? In the interval 0 to 1, f of 1 minus f of 0 divided by 1 minus 0, that equals f dash of c lying between 1 and 0. But we have found that f dash of x is always less than equal to 1. So that means this value is less than equal to 1 by 2, sorry. Okay, so that means if you multiply, you get f of 1 is less than or equal to 1 by 2. We don't know the exact value of f of 1, but at least we come to understand that f of 1 must be less than equal to 1 by 2. Let us draw the graph of y equal to f of x. So let us draw this. So this is the graph y equal to f of x. So let's draw this roughly. Okay, so here, so 0 to 1, right? Now here we know that f of 0 is 0, right? So f of 0 is 0. And what is the value of f of 1? So f of 1 here, we don't know the exact value, but at least we know that it is less than equal to 1 by 2. So that means somewhere here, right? So this is 1 by 2. Okay, so f of 1 is less than equal to 1 by 2. So that means it is maybe here, right? And also the derivative is this value, which is greater than or equal to 0. The derivative is always positive. That means it is an increasing function. The graph will not go up and down like this. It is an increasing function. Maybe like this. Okay, something like this. Okay, so this is the graph of y equal to f of x, the left hand side. Okay, drawn. Now similarly, we will draw the next one, that is 2x minus 1. So that is simple, a straight line. So at 0, what is the value? It is minus 1. What is the value at 1? At 1, the value is 2 minus 1, that is 1. So at 1, the value is 1. So that is a straight line. So just join this, that's all. Now these two curves intersect just at one point. Okay, so definitely these two curves will intersect, right? And not more than 1 point, because it is an increasing function. The graph of this function, that will not be like up and down, right? It will not intersect at more than 1 point because it is an increasing function. So the maximum number of intersections, that is only 1, and also exactly 1 point, right? So this is the point at which the two curves intersect. That means, so we have one solution. That's it. So this given equation has only one solution, right? So we simply draw the graph of the left hand side function and also right hand side. So we just find the number of intersections, that's it. But drawing this is very simple, but drawing this is a little bit difficult, right? We need to know the value at the point 0 and 1. So for that only we did all this calculation, right? So we found that f of 0 is 0, that is simple. But f of 1 we don't know exact value, but at least we've come to understand that f of 1 is less than or equal to 1 by 2. So that means the graph will be like this. So there is one intersection, that means one solution, okay? Here two functions are given, small f of x and capital F of x, and they are related. So this is the relation between them, small f of x equal to x multiplied by capital F of x. Using that we have to find some conditions satisfied by the function f of x. Alright, yes, it is given that the function f of x, so that equals x multiplied by this capital F of x. Alright, so let us find the derivative. So f dash x, so that equals x multiplied by f dash x plus f of x. Alright, so this is the derivative. Now we have to find f dash of 1. Okay, let us find it. So f dash of 1 equals, so 1 multiplied by f dash of 1 plus f of 1. Okay, so this f of 1 is given to be 0, so that becomes 0. So this is f dash of 1, so that is negative because it is given that f dash of x is negative, so f dash of 1 is negative. So that's all. So that is one relation. Okay, f dash of 1 is negative. So this is one answer, right? Now we also have to find the value of f of 2, I think, right? F of 2. Let us find f of 2. Now to find f of 2, so what we can do? See, now it is given that the derivative of the function, the capital F of x, is negative. Okay, so that means this is the function f of x. So between 1 and 3, so this derivative is negative and f of 1 is also given. So f of 1 is given to be 0 and f of 3 is minus 4. F of 1 is 0 and f of 3 is minus 4, and it is a decreasing function because the derivative is negative. It is a decreasing function, something like this. Okay, it is a decreasing function. So between 1 and 3. Okay, now between 1 and 3 x is positive, so if you multiply by x, again it is a negative value because it is always negative, and if you multiply by a positive value it is negative. So that means this capital small f of x is also negative. You understand? So capital F of x is negative, so that means small f of x is also negative because if you multiply by small x, so that doesn't make a difference in the sign. So f of x is negative, so particularly this f of 2 is also negative. Okay, so f of 2 is negative, so that is also there. So now similarly we have to find the f dash of x is not equal to 0. So can the derivative be equal to 0 at some point? Okay, f dash of x, can this be equal to 0? So let us check. So if f dash of x is 0, f dash of x is equal to 0, that means this value must be equal to 0, x multiplied by f dash of x plus f of x, so that must be equal to 0. Okay, yes. Now it is given that f dash of x is a negative value, okay, and x is a positive value, so that means it is a negative value, the whole value is negative, and also f of x is negative value. Okay, f of x is negative and f dash of x is also negative, the whole value is negative. You understand? So this is the negative value, so this will never be equal to 0. Okay, if one of them is positive, one of them is negative, so there is a chance that this becomes 0 at some point. So because f dash x is negative, that is given in the question, and also f of x is negative, so that we have drawn here, so the whole value is a negative expression, so never will this value be equal to 0, so negative. So that means f dash of x equals 0, so that is not possible. So f dash of x equals 0 is not possible. So that means, so for no value of x in that interval, f dash of x is 0. Do you understand? So that means, so this is the answer. It is a continuation of the last paragraph question. So in addition to that, it is also given integral 1 to 3 x square f dash of x dx. So this is given to be minus 12. So using that we have to find the integral f of x dx. Let's find it. So now we have to use integration by part, right? Obviously, right? So u v. Okay, so integration by parts. So u multiplied by integration of that. That means x square multiplied by f of x. So that is the integration of this, and the limit is from 1 to 3 minus integration of the derivative of x square, that is 2x multiplied by, so that is f of x. So that equals minus 12. Okay, yes. So 1 to 3 Okay, so now if you do the substitution, 3 if you do substitution here, 9 multiplied by f of 3, but f of 3 value is given minus 4, so that is 9 multiplied by minus 4 minus, now you substitute 1, f of 1 that is 0, okay, minus 2 times integral 1 to 3 x multiplied by capital F of x, so that is what is given as small f of x, okay, so that equals minus 12. So this will give you our required answer, integral, so 1 to 3 f of x dx, so that equals, so what is that value, so this is 36, 12, so 24 divided by minus 2, so that is minus 12. Yes, now we also have to find the relation between f dash of 3 and f dash of 1. Okay, so let us find it. For that we have to use the other integrand given, right? So it is 1 to 3 x cube f double dash x dx. So that value is given to be 40. Alright, yes. Now we have to use the same method, right? Integration by parts, right? So u and this is v. So what do you get? So this is u multiplied by integral of this, that is f dash x. So that means x cube multiplied by f dash of x, so limit is from 1 to 3, and minus integral u dash, so that is 3x square multiplied by f dash of x dx, so that must be equal to 40. Okay, let's substitute this. So if you substitute this 3 here, so we get 27 f dash of 3 minus 1 if we substitute, we get f dash of 1 minus 3 into, see, x square f dash of x, so this integral is already given, 3 multiplied by integral 1 to 3 x square f dash of x dx, so that is what is given as minus 12, so minus 12, so that equals 40. Okay, now f dash of 3, f dash of 1, but in the option we have to find the relation between small f dash of 3 and small f dash of 1, not capital X, but capital F and small f are related, right? So this is the relation. Let's do it separately. So it is given that this f of x is equal to x multiplied by capital F of x. Let's find the derivative. So f dash x equals x multiplied by f dash of x plus f of x. Okay, now we want f dash of, say, f dash of 3. Okay, so let us substitute here 3. F dash of 3 equal to 3 multiplied by f dash of 3. So what is f dash of 3? So let's write it as it is, and then f of 3 is given as minus 4. Okay, so f of 3 is minus 4. This is one relation. Okay, we can use it here. Okay, f dash of 3, so we can substitute here. Now similarly we can substitute 1. So f dash of 1, what is f dash of 1? So 3 multiplied by f dash of 1. Okay, sorry, 1 multiplied by f dash of 1, 1 multiplied by this capital F dash of 1, so plus f of 0, that is f of 1 is 0. So that means we've got small f dash of 3 and small f dash of 1 in terms of capital F dash. Okay, so that can be substituted here. This 27 can be written as 9 multiplied by 3 f dash of 3. But what is 3 f dash of 3? So 3 capital F dash of 3 is, so small f dash of 3 plus 4. Okay, so that can be substituted here. Small f dash of 3 plus 4 minus, what is f dash of 1? But f dash of 1 and capital F dash of 1 both are same. So that means we can write it as f dash of 1 plus, so this is 36 equal to 40. Okay, let's simplify this. So this is 9 times f dash of 3 minus f dash of 1. Okay, so this is 9 multiplied by 4, 36 plus 36, so that is 72 minus 40, so that is 32. So plus 32 equal to 0. So that's all. So this is one of the options C. So 9 f dash of 3 minus f dash of 1 plus 32 equal to 0. So that is one of the options, right? So this is the relation between small f of x and capital F of x. So that is made use of here, okay, to get small f dash of 3 and f dash of 1. Okay, yes. So this is the answer, and also we have integral 1 to 3 f of x dx, so that equals minus 12. Okay. Here a function f of x is given, we have to find two integrals, integral 0 to pi by 4 f of x dx, and also we have to find integral 0 to pi by 4 x times f of x dx, right? So let us find these two integrals one by one, right? First of all, let's simplify the function f of x. So the function f of x is given as 7 tan x to the power 8 and similarly plus 7 tan x to the power 6. Now from the first two terms you take common 7 tan x to the power, so tan to the power 6x. So if you take out, so that will become tan square x tan square x plus 1. Alright, so that is the first two terms. Okay, similarly from the next two terms we can take out the common factor, which is minus 3 tan square x. Then you will get tan square x plus 1. So this tan square x plus 1 can be written as secant square x, so that can be taken as a common factor. So we will get 7 tan to the power 6x minus 3 tan square x multiplied by this tan square x plus 1, so that is secant square x. Okay, now we have to do the integration. So first let us do the integration. So 0 to pi by 4 f of x dx. Okay, f of x dx, so that equals, so integral 0 to pi by 4, so this function, okay, 7 tan to the power 6 minus 3 tan square x multiplied by secant square x dx. See, obviously to do the integration we have to take the substitution t equal to tan x, because its derivative dt is secant square x, so that is there. So that means if you take the substitution, so the limit will change to 0 to 1, so 7t to the power 6 minus 3t square dt. So this will become dt, right? So just do the integration, so that will give you the value of this one. Okay, so 7t to the power 7 divided by 7. So that means, so I'm just writing directly, so t to the power 7 by 7, so t is 1. Okay, so that means 7 divided by 7, so 1 minus again 3t cube divided by 3, so 3 by 3, so that is also 1, so that means 0. So 0 is the value of integral 0 to pi by 4 f of x dx. Alright, so that is one of the answers. Now similarly we have to find the next one, integral 0 to pi by 4 x f of x dx, x multiplied by f of x dx. So it is 0 to pi by 4 x multiplied by f of x we have written here, so that we can use, so it is 7 tan to the power 6x minus 3 tan square x multiplied by secant square x dx. So what we have to do, we'll use integration by parts, right? X is there and this function, so whose integral we can find easily, right, by the same substitution method. Okay, so let us use the integration by parts. So this can be taken as v. So what is that? Integrate u multiplied by u is x multiplied by integration of this. So integration of that is, we know that, right? Same thing, 7, we have to take the substitution, but I'm writing directly 7 this to the power 7 divided by 7. So that means it is tan to the power 7x minus similarly tan cube x. Okay, so this is the integral, so 0 to pi by 4. Now done. Minus the next term is integral of, so du by dx, so that is derivative of this, that is 1 multiplied by the integral of this, so the integral of that is this one, tan to the power 7x minus tan cube x dx. Okay, so this can be substituted, right? Substitute this value, right? Pi by 4 if you substitute, so this is 1 minus 1 0, 0 if you substitute 0, so the whole term becomes 0. Only this term we have to find. But how to find this integral? So for that again we have to use a similar method. So tan to the power 7, we can take out some common factor, right? So let us simplify that. So how to simplify that? So that equals minus, so we can take out a common factor, that is tan cube x. So integral of, say, tan cube x, if you take out, you will get tan to the power 4x minus 1. So that can be further simplified, that is tan square x minus 1 multiplied by tan square x plus 1 dx. Okay, like tan to the power 4 minus 1, that is factorized. Now this tan square x plus 1 is again written as secant square x. We need secant square x to find the to do the substitution. Only then we can use that dt here. So this becomes, okay, we write here, so integral tan cube x, okay, tan cube x, this is tan square x minus 1. So if you multiply this, you get tan to the power 5x minus tan cube x multiplied by, this is tan square x plus 1, so that can be written as secant square x dx. Okay, now it is obvious we have to take tan x as t. Take tan x equal to t. Now the limit is from 0 to pi by 4, so this integral will change to this one, so minus of integral 0 to 1, so that is t to the power 5 minus t cube, this is dt. So that if you do the integration of this is t to the power 4 divided by 4 minus t to the power 6 divided by 6, So the limit is from 0 to 1. So that's it. So this is 1 by 4 minus 1 by 6. Okay, so if you simplify this, this is 3 minus 2, 1 divided by 12. So that's all. So that is the required answer, right? So it is very simple. Now we just directly substitute the function f of x, but you have to simplify f of x. That is important. This type of simplification is important. So the moment you have tan x, so we need that secant square x so that we can find the integral using substitution method, right? So that's it. So this is integral 0 to pi by 4 f of x dx, that is 0. And similarly, so integral x f of x, so that has value 1 by 12. Okay. Here f dash of x is given, the derivative of the function f of x. Now we have to find the range of the integral of f of x. So first of all, let us find the range of the function f of x. Or first of all, we will find the range of the derivative of the function, right? So f dash of x is given here. So that is, so this is the derivative of the function. So f dash of x, so that equals, so 192 x cube divided by, so 2 plus sine to the power 4 pi x. So this is the function f dash of x. So let us find the range of this. See here, this function, right, has maximum value 1, right, because sine to the power 4 pi x, so that has maximum value 1. So that means the whole function to have maximum value, this should be minimum, right? So let us substitute the minimum value of this, that is 0, right? So sine to the power 4, minimum is 0, maximum is 1. So let us keep the numerator as it is, only write the maximum and minimum value of the denominator. So the function f dash of x here is less than or equal to, so now we write the minimum value of this, so that we'll get the maximum value of the entire thing. So minimum value of this is 0. So now 192 divided by 2 x cube. So that equals, right, so that is 96 x cube. So this value is always less than or equal to this. Okay. Similarly, greater than or equal to, now here we write the maximum value of this. If you write the maximum value of this, that is 1, we will get the entire thing, right? So that is minimum. So what do we get? So 192 divided by 3. So that equals, right, so 64 x cube. So our function f dash of x lies between these limits. Now let us do the integration because we want f of x. Let us do the integration. So let's do the integration within this limit, right? We'll integrate from 1 by 2 to x. Okay, variable limit. So 1 by 2 is the lower limit given in the question. So 1 by 2 to x. So same function 64 x cube dx. That is less than equal to integral 1 by 2 to x f dash x dx. That is less than equal to 1 by 2 to x 96 x cube dx. Okay, so now we will do the integration, right? So 64 x to the power 4 divided by 4. So that means, so 64 divided by 4. So that is 16 x to the power 4. So from 1 by 2 to x. Similarly, now if you do the integration of f dash of x, that is f of x. Now if you substitute the upper and lower limit, so that is f of the upper limit, that is x minus f of 1 by 2, right? After integration, we've just substituted the limits. Now 96 x to the power 4 divided by 4, so that is 24 x to the power 4. So again, the limit is from 1 by 2 to x. Okay, yes. Now, so let's substitute here. So 16 x to the power 4 minus, so this 1 by 2, right? 16 divided by 16. So that is 1. So that is less than or equal to f of x. Now this f of 1 by 2, so that is given in the question, right? So that is given to be 0. So this is gone. So less than equal to, so this one 24 x to the power 4 minus, now if you substitute 1 by 2, 24 divided by 16. So that is 3 by 2. That means our function f of x lies in this range, okay, f of x. Now if you do the integration, we will get the required answer. So we want to find the integral f of x dx from 1 by 2 to 1. So let us do the integration again. So here 1 by 2 to 1, so it is 16 x to the 4 minus 1 dx. So that is less than equal to 1 by 2 to 1 f of x dx. So that is less than equal to, again, 1 by 2 to 1, 24 x to the power 4 minus 3 by 2 dx. Okay, so that's it. Simplify this. This is 16 x to the power 5 divided by 5. So that is same as, okay, so 16 x to the power 5 divided by 5 minus x from 1 by 2 to 1. So that is less than equal to our required integral. So f of x dx. So that is less than equal to, so this integration, so that is 24x to the power 5 divided by 5 minus 3x by 2. So from 1 by 2 to 1. Okay, so now here it is just a calculation here. Okay, let us do the calculation now. So 1, if you substitute, so we'll get 16 by 5 minus 1. Okay, and minus of, so 1 by 2, if you substitute 1 by 2, this is 16 divided by 32, so that is 1 by 10 minus 1 by 2. So that is less than equal to, so this is 1 by 2 to 1 fx dx, that is less than equal to, let's substitute 1 here, 24 divided by 5 minus 3 by 2 minus of, if you substitute 1 by 2, 24 divided by 32, so that is 3 by 4, so that means 3 by 20 minus 1 by 2, if you substitute, you get 3 by 4. So this is the range. Now we have to just do the simplification. So this range is integral 1 by 2 to 1 f of x dx, so that lies between, so if you do the calculation, so let's simplify this. Okay, so now if you do the calculation, so this will come out to be something like 13 by 5, right? You can do the simplification. Now this is 17 by 5. So this is the range in which this function lies, but that is not given. Now you have to see which one of these options matches here. Now we know that 17 by 5 is less than equal to less than 12. So 17 by 5 is less than 12, and also this 13 by 5 is greater than 1. So that's also, that is the range. We need not find the exact value, right? Because we only need the inequality. So we've got this integral lying between 13 by 5 and 17 by 5. So obviously it will lie between 1 and 12. So that is the answer. So this integral, right, integral f of x dx from 1 by 2 to 1, that lies between 1 and 12. So that is the answer.